SpaceX's Starship-Super Heavy rocket is back again at the launch pad. This time, it's Starship version 3.
Generally, with any new technology, it takes three major iterations of any new technology to have it really work well. And this, with Raptor 3 and Starship and Booster version 3, it should be able to achieve all of the things that I just mentioned, which is a rapidly reusable, reliable rocket with orbital refilling.
Starship version 3 features some major design changes and upgrades, from the structures, to the engines, to the avionics, and more. The upcoming mission, dubbed Flight 12, is also the debut of Launch Pad 2 at Starbase.
Version 3 is what I like to call the foundational design of Starship Booster in the pad. That's going to give us the new capabilities we need to do the missions in front of us. It'll be the one that puts humans back on the moon. It'll be the ones that put the first blueprints and then city on Mars.
Whether Flight 12 launches on time or maybe slips a day or two, the debut of Starship version 3 is a critical moment for SpaceX. Here's why. Flight 12 comes about 7 months after SpaceX last launched a Starship rocket. Flight 11 was back on October 13th of 2025. Its success let SpaceX end that year of Starship testing on a high note. 2025 was a year that started with 2 test launches that underperformed and a testing site explosion that not only resulted in the loss of the upper stage, called Ship 36, but also heavily damaged SpaceX's testing site, called Massey's.
Ship 36 was a tough one. We had a CPV explode, and it not only took out the rocket, but it took out a lot of the test site infrastructure over at Massey's. Losing a rocket is one thing. We've got a production line for rockets and we can go make more. Losing the physical infrastructure of the launch pad or the test site is very difficult because you need to go repair that over a period of many months before you can get back into testing.
All the missions that flew in 2025 were version 2 of Starship. Version 3 was seen as the sweet spot for the next giant leap in capabilities for this launch vehicle.
Basically, all of the ingredients necessary to make life multiplanetary will be achieved with version 3 of Starship, which we're aiming to launch for the first time at the end of this year.
That was SpaceX founder Elon Musk speaking at Starbase back in May 2025. As you heard, Starship version 3 was expected to debut in 2025, but the timing of Starship version 3 becoming reality was hindered in part by the setbacks seen during the version 2 test campaign.
It looks like we are losing attitude control of the ship.
In the first episode of a new docu-series published by SpaceX, the company notes that it also faced some challenges with the hardware for version 3. One notable example came on November 20th, 2025. On the schedule that day, work towards a cryo-proof tanking test of Booster 18, which was intended to be the first version 3 Super Heavy booster to fly.
When we were pressing the nitrogen system, we had an explosion that took out the rocket, and thankfully we had designed that test to be safe. If something like that happened, we did not have propellants or reactive things on the vehicle, and so the test site incurred very little damage, and of course nobody was hurt in the incident.
With Booster 18 gone, that meant Booster 19 would be on deck for Starship Flight 12, flying alongside Ship 39. Let's talk about some of the key upgrades to the rocket. And let's start with the new Raptor 3 engines.
Raptor 3 is designed to require no base heat shield, saving a lot of mass on the bottom and actually improving reliability so that if there is, for example, a small fuel leak from the Raptor engine, it will simply leak into the existing flaming plasma and not really matter. Whereas a fuel leak when the engines are contained in a box is a very scary thing indeed. So this is a Raptor 3. It'll take it probably a few kicks at the can, but it is a massive increase in payload capability, in engine efficiency, and in reliability. So this is really a revolutionary engine.
The Raptor 3 engines were first publicly shown off by SpaceX in August 2024. They were displayed alongside the previous iterations of the Raptor engines down at Starbase. At the time, SpaceX showcased the following stats for performance and mass for each engine. But as testing progressed these past 2 years, so too did the engine design. SpaceX now says the sea-level version of the Raptor 3 engine provides about 250 tons of force or 551,000 pounds of thrust at liftoff. That's about 30 tons less than estimated back in 2024. Spaceflight now reached out to the company the morning of May 14th to ask what changed between the 2024 social media post and now. We did not hear back prior to publishing this video report.
If you're liking this video, you don't have to just watch. Click like, share, and subscribe, and be sure to turn that bell icon on. That way you'll be notified when all of our videos go live and we begin a new live stream. And if you want to further support what we do here at Spaceflight Now, consider becoming a paid channel member. That way you'll get exclusive access to our reporting, as well as some behind-the-scenes videos from our photographers, and most importantly, you'll be supporting independent coverage of NASA and the space industry.
Extensive testing on these engines is done at SpaceX facilities in McGregor, Texas, about 460 miles from Starbase. That included this validation test performed on engine number 75. Multiple versions of this test will cover the different conditions seen by Starship's 3 inner engines during its initial climb to space, SpaceX wrote in a post on X in December 2025. The upper stage of Starship version 3 includes many upgrades, including what SpaceX calls a, quote, clean sheet redesign of its propulsion systems. The company wrote, these changes enable a new Raptor startup method, increase propellant tank volume, and improve the reaction control system used for steering while in flight. The propulsion updates also reduce contained volumes in the aft end of the vehicle that could trap propellant leakage.
We essentially took a bunch of lessons from version 1 and version 2, and we took a step back and said, what were the things that were really problematic, either from a performance perspective or from a reliability perspective on the previous rockets? And then we directly addressed those with a variety of new designs.
One of those new designs involved going from 2 down to 1 actuator on each of the aft flaps. SpaceX says that, quote, improves redundancy for return to launch site operations while reducing mass and cost. The ship is now designed to support on-orbit flights of around 48 hours, thanks to features like redesigned reaction control systems and a dedicated system to aid with propellant interactions with the engines. The ships now also feature docking adapters, as well as several avionics advances that will help with future ship-to-ship propellant transfer. Musk discussed the concept back in May 2025.
The 2 starships would get together, and one starship would transfer fuel and oxygen. And actually, most of the mass is oxygen. It's almost 80% oxygen that gets transferred, a little over 20% fuel. And so once you send a starship to orbit with that's full of payload, and then you send a bunch of other starships up, and you would refill the propellant on that starship. And once the propellant tanks are mostly full, then you can depart for Mars or the Moon, or yeah. So this is an important technology which we should hopefully demonstrate next year.
Big changes were also made to the new Super Heavy booster as well. SpaceX sprinkled those announcements across 2025. For instance, SpaceX introduced the redesigned fuel transfer tube that will bring the liquid methane down to the 33 Raptor engines. For size comparison, SpaceX notes that it's roughly the same size as the first stage of a Falcon 9 rocket. SpaceX says this larger size will allow all 33 Raptor engines to start up simultaneously instead of a staggered start time. Then, in mid-August, SpaceX shared these photos of the new grid fins. It said these were 50% larger and also stronger than their predecessors. They also include new catch points to support lifts and catches. During Starship Flight 11 back in October, SpaceX's Dan Hewitt talked about replacing the single-use hot stage ring at the top of the Super Heavy booster as well.
New booster are also going to have an integrated hot stage, a lot more vent area, and it's designed to be fully reusable. Pressure from those engine plumes gets vented out, mostly offset just by the pressure in the fuel tank. That is the top of the fuel tank. And then we add a non-structural layer of steel on the top that helps take all the heating. It's mapped to where all the high heating goes.
The aft end of the Super Heavy booster also got a redesign, creating a closer integration between the avionics and propulsion systems. SpaceX also says it removed individual engine shrouds and added more shielding, quote, to the surface area between engines and around the thrust vector control hardware on the inner 13 engines. Meanwhile, the new launch pad, called Pad 2, features a propellant farm with increased storage and more pumps to allow for a faster fueling timeline. Tanking used to begin around 45 minutes before flight, but now it's down to just under 39 minutes. That's 4 minutes longer than it takes to fuel a Falcon 9 rocket, but for comparison, the Starship rocket has 11 times more cryogenic propellant flowing on board. The tower on Pad 2 also features shorter chopstick arms for faster actuating, and those actuators are now electromechanical, not hydraulic as with Pad 1. Pad 2 also features a new bidirectional flame diverter and improved launch mount and hold-down clamps. The Flight 12 hardware got to test all of this out for the first time. After the Booster 18 rupture in November, Booster 19 completed stacking in the Mega Bay just before the end of December. It rolled out in early February and made its way over to the Massey's test site for the beginning of cryoproof testing. Thankfully, that went much smoother.
Cryoproof is the first time you actually put propellant onto the vehicle. The liquid propellant that we're putting on, it does get pretty cold, generally in the 80 Kelvin range. We want to test like you fly and fly like you test.
While Booster 19 progressed, Ship 39 emerged from the Mega Bay for the first time in late February and also headed for Massey's. Over a several-day period, it went through its own test campaign. Engineers tested the vehicle's redesigned propellant system and its structural strength, including squeeze tests to mimic the forces of future ship catches, SpaceX wrote on X. It announced this round of testing was complete on March 7th. Booster 19 then re-emerged at the production site days later, and SpaceX rolled it out to Pad 2 in preparation for a 10-engine static fire test on March 16, 2026. However,
abort. On LBN1, looks like we kicked out 2 combustors from the apex bank being pelted.
Looks like we have to engine time of 2.135 seconds.
We successfully lit all 10 engines. They were ramping up to power. Everything was looking good, stage and engines combined. However, there was a pad side abort called. So what that means is some sort of sensor tripped, and from there we command a fast shutdown.
It was a hard one, and especially since we had to drop all the engines afterwards, and thankfully 10 of them were salvageable, which is good.
We saw some data right after static fire that showed about half the engines had what looked like mechanical damage, basically as a result of the really fast shutdown. So we brought the booster back to Mega Bay. We then decided to remove all 10 engines from the booster so that we could troubleshoot and understand what's going on those 10 while still making progress on B19 by backfilling engines from B20.
Booster 19 would go back to Massey's for more cryoproof testing, which SpaceX says wrapped up on April 5th. About a week later in April, both Ship 39 and Booster 19 emerged once again at the production site at Starbase to continue pre-launch testing.
Startup.
For Ship 39, that meant a full-duration static fire test at Massey's. And for Booster 19, a 33-engine static fire test at Pad 2. But once again,
We kicked out early. All teams triage alerts, prepare for offload.
pad issues reared their ugly heads.
We aborted our second attempt of the B19 full count static fire. We actually had another pad abort on the diverter. We made it through engine startup and then ultimately lost some of our sensors on one of the ramp manifolds. It basically said that the manifold pressure was lower than we believe that it probably was, and it kicked us out at T plus 1.88 seconds. It's just tough because there are some things that are hard to test ahead of time. So the diverter, you can test as much as you want, but you can't obviously test for what theoretical vibe and environment you're going to see when the engines are turned on.
After some additional troubleshooting, on May 7th, SpaceX finally completed a full duration and full thrust 33-engine static fire with Booster 19. A couple of days later, Ship 39 rolled out to join Booster 19, and the full stack completed a wet dress rehearsal tanking test on Monday, May 11th. Now, all the pieces are laid out. The stage is set for the beginning of the Starship version 3 era. NASA is counting on this version of the rocket to get good test data and pave the way for the human landing system version of the rocket. It's critical hardware for the crewed moon landings for the Artemis program. SpaceX also needs a successful Starship version 3 for the next generation of its Starlink satellites and many other eager customers.
This is a tentative game plan here.
And with SpaceX on the verge of going public for the first time, prospective investors are also eagerly awaiting to see how Starship version 3 propels the company into the future. And it all starts with Flight 12. Reporting for Spaceflight Now, I'm Will Robinson Smith.